Hi, in this video we'll be covering balancing reactions. So in any chemical reaction, you start off with your reactants and then they react to give you your products. The idea of balancing reactions is very simple. All you want is to have the same amount of atoms on the reactant side as the product side. Let's do an example. A simple procedure for balancing reactions would be to make a table like this, where you separate the reactants and the products on two different sides, and then you just write out the different types of atoms on the left side. Now we count up and see that we have 1 carbon on the reactant side, 4 hydrogen, and 2 oxygen. On the product side, we have 1 carbon, 2 hydrogen, and 3 oxygen. And since the two sides are not equal, we can say that the reaction is not yet balanced. Something to notice before we start is that we have one type of isolated atom here. Since oxygen is isolated, it means that we should balance it last, because we have full control over it. We also see that carbon is already balanced, which means that we're left with balancing hydrogen. We see that there's twice the amount of hydrogen on the reactant side as the product side. As this water is the only molecule contributing hydrogen, we start by multiplying this by 2. This way we have 4 hydrogen, which makes hydrogen balanced. But by multiplying water by 2, we also get 4 oxygen. We now have to go back to our isolated oxygen molecule and multiply it by 2. This way we see that we have 4 oxygen, and since both sides are equal, we can now say that the reaction is balanced. Let's do a couple of exercises. The first exercise is to balance this reaction. So let's do what we usually do by drawing a table where we separate the reactants and the products. And then we just write out different types of atoms. Let's count. We see that we have 1 phosphorus, 5 chlorine, 1 oxygen, and 2 hydrogen on the reactant side. And on the product sides, we have 1 phosphorus, 4 chlorine, 1 oxygen, and 1 hydrogen. So we see that phosphorus and oxygen are already balanced, so we just need to focus on chlorine and hydrogen. And we see that we're missing 1 of each, which is great since we have hydrochloric acid here, which contributes 1 of each. So by multiplying this by 2, we see that we have 5 chlorine and 2 hydrogen, which balances the reaction. For the second exercise, we want to balance this reaction. So let's make our table with phosphorus and chlorine, and then we count that we have 4 phosphorus and 2 chlorine on this side, on the reactant side, and 1 phosphorus and 3 chlorine on the product side. So where should we start? Since we have one isolated type of atom here, which is chlorine, we should start by balancing the other one, which is phosphorus. So we see that we have 4 phosphorus on the reactant side, but only 1 on the product side. So we multiply this by 4. And by doing this, we see that we have 4 phosphorus and 12 chlorine. So now we can balance the chlorine, multiplied by 6 to get 12 chlorine, which balances the reaction. Let's do 2 more examples. For this example, we want to balance this reaction. So let's make our table with the products and reactants. And then we write the different atoms. And then we count. So we have 1 iron, 2 hydrogen, and 1 oxygen on the reactant side. And we have 3 iron, 2 hydrogen and 4 oxygen on the product side. So notice that both iron and hydrogen are isolated, which means that we can start by balancing oxygen. In this case, we have 4 times the oxygen on the product side as the reactant side. So we start by multiplying this by 4. This way we have 4 oxygen, but we also get 8 hydrogen. So let's balance hydrogen then. Since it's isolated, we can just multiply this by 4. And by doing this, we also get 8 hydrogen on the product side. Now we just need to balance iron, and we do this by multiplying iron by 3 on the reactant side to get 3 iron. So now we see that the reaction is balanced. For the last exercise, I want to show a new technique called balancing by fractions. So this is the reaction we want to balance. We start off the same way by making a table with our reactants and products and the different atoms. And then we count to see that we have 1 iron and 2 oxygen on the reactant side, and 2 iron and 3 oxygen on the product side. So we see that it's quite simple to balance iron. We just multiply by 2 to get 2 iron, which balances iron. Now we just need to balance oxygen. But we see that there's no way to multiply 2 by an integer to get 3. So instead we have to balance by a fraction. We can do this by multiplying oxygen by 1/2. This way we get 1 single oxygen atom, and if we multiply by 3 now, we get 3 oxygen atoms. But we don't want fractions in our expression, which means that we have to multiply the whole expression by 2. This way, if we rewrite the equation, we get the coefficients to become 4, 3, and 2. If we count up now, we see that we have 4 iron and 6 oxygen on the reactant side, and 4 iron and 6 oxygen on the product side as well, which makes the reaction balanced. We have now covered how to balance reactions. In the next episode, we'll cover states of matter. See you then.